Hello, everybody. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Concord, New York. There's my contact information. We are doing lesson number 5 and unit 6 for Common Core Algebra 2. This is the non-regents group. In the packet, it's page 17 to 20. If you don't understand what I say, you can always go scan that QR code for the genius that wrote these worksheets, and he will explain it to you in his videos. Now, we've essentially 3 types of factoring. We did the greatest common factor, dots, difference of 2 squares, and trinomials. So what happens when we have a cube, when we have 3 things, when we have x cubed? So what we're going to learn is how to do some factor by grouping, and hopefully that'll solve that problem. So if we notice, factoring a binomial, if it has common factors out of each of the following expressions, right? Your final expression is the product of 2 binomials. So it's telling us to look for something and factor it out. And that's something that's telling us to look for is a binomial. So here's something that's 2 parts. Notice that we have the x plus 2 and the x plus 2. We can factor it out. Now, what does this really look like? To a mathematician or a person who's been doing this a while, it looks like x times monster plus 7 times monster. This is just a monster. It's kind of scary. But if you notice, we can factor out a monster. So it looks like monster and then x plus 7. Well, that's the same thing that we're going to do up here. Now we know that the the monster is 2x plus 1. So I can factor out 2x plus 1. And I'm left with an x plus 7. It's as simple as that. Take a look to see what's the same. We have an x minus 2 that's the same. So we factor out the x minus 2, and what are we left with? We're left with 5x minus 4. Take a look, try to see what's the same. Oh yeah, there it is, the x minus 7. So we factor it out. And then we have the x plus 5. Ooh, tricky. And then we have to add on to that x plus 1, and we're going to have a double set of parentheses, so I'm going to change that into brackets. So that's kind of tricky there. Why didn't I multiply those together? Some of you might be asking. Well, it says add it. Add it. We have to factor out the x minus 7. The x minus 7 comes out front. Now, you're like, hey, I don't believe you. I don't believe you that these two things are exactly the same. Well, here we can take this x minus 7 and distribute it. X minus 7 times the first part, x plus 5, and then add on to it the x minus 7 times x plus 1. So I just distribute it, and you're like, well, it doesn't look the same to me, Mr. Bryce. Well, that's because we commuted it. We changed the order. But the commutative property of multiplication lets you change the order. So it checks. It checks. This is the final answer, but that's just a check to make sure you did it right. So now we take a look at here. We have an x plus 4 and an x plus 4. Okay. I wonder if I want to do something else with that. I just realized I looked up directions. It says, yeah, let's just do a product of 2 binomials. So I did not simplify this enough. This should have been added together to be 2x plus 6. No big deal. I just want you to see the concept here. If we pull out the x plus 4 and you're looking at this and you're saying there's something hiding in there. There's a factor hiding in there. I'm just going to rewrite that because I saw that there was another x plus 4 hiding in there. So that's what I jotted down. So let's take this a little slow. If I factor out an x plus 4, I'm going to factor out an x plus 4 there. I'm going to take that out. So I have x plus 4. And what am I left with? I'm left with a 2. I'm left with an x plus 4. I'm left with a minus x minus 2. So why can't I factor out another x plus 4? Well, because I can't take an x plus 4 out of there. Remember, when I factor it out, it's going to have to be multiplied by both parts. Okay, it's a greatest common factor. It has to be a common factor that's not common. It's not common, so I can't take that out. So what I have is I have x plus 4, and then 2x plus 8 minus x plus 2. Okay, I just, distributed the negative sign through, and that equals, to make it into a binomial, x plus 4, 2x minus x is x plus 8 plus 2 is plus 10. Okay, now rewrite the expression x plus 3 times x minus 4 plus 5x plus 3 is an equivalent product of binomials. Test this when it equals 2. So do we have a common factor? We have something that goes into both of them. That's x plus 3. And we're left with an x minus 4. And we're left with a plus 5. So this is really x plus 3 times x plus 1 when I combine the terms. It says plug in 2. When I plug in 2, 2 plus 3 times 2 plus 1 is 5 times 3, which is 15. Now, once we plug in 2 there, so I'm just going to do the arithmetic. 2 plus 3 is 5, and then 2 minus 4 is negative 2 plus 5, and then 2 plus 3 is 5, so the whole thing is 25. Negative 10 plus 25 equals 15. It checks. Okay, so now we're going to get to the heart of factor by grouping. And what do we have to do? We have to group them, put them in groups, put them in groups. Okay, but what kind of groups do we have to put them in? We have to put them in groups that make sense. Okay, just like these groups up here, they kind of make sense. Okay, they're grouped together. So now we take a look at this problem and say, somehow if I look at this part, I can see that that's a 5 and an x minus 3 when I look at that. And now I can say, is this going to be, can I get an x minus 3 out of those? Oh yeah, if I group those together, I can get an x minus 3. And so we group it, and we factor out a 2x squared, and we're left with an x minus 3. When we group it, we factor out a 5, and we're left with an x minus 3. So the x minus 3 and the x minus 3 gets factored out, and we're left with 2x squared plus 5. Okay, so the whole thing is x minus 3 and 2x squared plus 5. And so why can't I use the Xbox on this next page? Well, you can't use the Xbox because there's no common factor of x in all 4 parts. Okay, there's no, and since we have an x cubed sitting there, we don't know how to factor a trinomial. So let's try factor by grouping. So our goal is to try to get this down to, either a trinomial with, x squared, or, to see if we can get a binomial out of here. Get 2 things out. So use your brain and think about it. And obviously, you start to look at stuff that's side by side. And when you take a look at this, I can say, well, I can factor out an x squared. And if I factor out an x squared, I'm left with a 3x plus 2. Now, am I going to get a 3x plus 2 here? Well, there's the negative sign right there. So if I change that to, let me see, if I change that to minus 27x plus 18, okay, I factored out a negative 1. There we go. And now let's do x squared 3x plus 2. And remember, my goal is to try to make this look like either an x squared. I want this to look like an x squared, or I want it to look like a 3x plus 2. So why don't I have it look like a 3x plus 2? If I 27 divided by 3 is 9. Oh, so I can divide everything by 9. The greatest common factor between 27 and 18 is 9, and I'm left with a 3x plus 2. Oh, cool. Now I have 3x plus 2 factored out, and I'm left with an x squared minus 9, in which I immediately want to look at the directions. So use this method of factoring by grouping. Completely factor the following expressions. Why do I want to why do I look at that? Because I recognize the x minus 9 as a difference of two squares. 3x plus 2, and then you can either use the x box, or when you think of difference of two squares, you think, let me see, x squared plus 0x minus 9. What two numbers multiply to be negative 9? That's the product, and they have to add up to be 0. Oh, that's 3 and negative 3. So x plus 3 and negative 3, so it's x minus 3. And there we go. It's factored completely. So again, I'm looking at the first two parts and that part, and I can see that it's divisible by 9. We have a common factor of 9, and we have a common factor of x squared. So why don't I just take that out and see what I have? I take out a 9x squared, and I'm left with a 2x plus 1. Okay, now how can I get this part to look like 2x plus 1? I can factor out a negative 1 plus negative 1, and then 2x plus 1. I really should have just turned that into minus. You know, it makes a little more sense there. Now I can factor out the 2x plus 1. When I factor out the 2x plus 1, yep, I'm left with 9x squared minus 1. Factored completely. What do you mean? It is factored completely. No, it's not. 9 is a perfect square. 1 is a perfect square. When you ever have a binomial and there's a square there, you should check to make sure it's not a difference of two squares. So 2x plus 1. What's the square root? Remember, you can take the square root of 9. It's 3x minus 1 and 3x plus 1. Difference of two squares. When we're subtracting, what's the difference? It's the square. You take the square root of 9, put it there. The square root of 1, put it there. One of them is plus, one of them is minus. C. What just happened? Hang on a second. Beautiful glitches of the computer system. So let's take a look at C here. So again, I'm looking at the first part and I'm saying, is there a greatest common factor there? Yes, x to the third. And then I'm left with x squared plus 4x, plus 4, sorry. And now, can I somehow get, in that part right there, can I get an x plus 4? Yeah. If I factor out a 2, I'm left with the x squared plus 4. Now factor out the x squared plus 4. This is not a difference of two squares because it's not difference, it's not subtract. X cubed plus 2. go to D. We can go through this problem and then see that we can factor out some more, or the fact that I see that they end in a 5 or a 0. So I'm going to factor out the 5, and then I'm left with x cubed plus 2x squared plus 4x plus 8. I'm going to carry along the 5 for the fun of it. I see that I can factor out an x squared there, and that would leave me with an x plus 2. So is there any way possible I can get an x plus 2 there? Yeah, I can factor out a 4 and I get an x plus 2. So why don't I go ahead and I'm going to change these to brackets, and I'm going to factor out an x squared, and I'm left with an x plus 2 because that's the greatest common factor that I pulled out, and then plus factor out a 4, and I'm left with an x plus 2. The 5 comes along for the fun of it. I'm left with, I factor the x plus 2, and I have the x squared plus 4. I can't factor out the x squared plus 4 anymore because it's called the difference of two squares, not the addition of two squares. So we're done. I'm just going to take a moment here to explain why this works one more time, just like I did before. So I'm going to take that line and I'm going to rewrite it. It's 5, then x squared times a monster. The monster is x plus 2, plus the 4, and then the x plus 2 is just a monster. So when I'm factoring this part, x squared monster plus 4 monster, they have a common factor. They have monster together. Okay, so I'm left with 5, and then factor the monster. And what am I left with? I'm left with the x squared, so the x squared has to be written down. I'm left with a positive 4, so the plus 4 has to be written down. But the monster was just x plus 2, so instead of writing the monster, we can write x plus 2. Okay, so I'm going to skip over number 5 and skip over number 6, just for timeliness matters. And your homework is the next 2 pages, number 1, 2, and 3, and number 4. Wait a minute, what about number 5 and 6? Skip number 5, skip number 6. If you have any questions, make sure you ask me in class. Have a great day.